Welcome to the Bell Tech Talk segment of the Vertical MRO podcast. This segment takes you into the nuts and bolts of helicopter maintenance. It's about safety, support, and operational readiness. Top priorities for the Bell team. Join us for technical insights and personal stories from the front lines of helicopter maintenance from the industry-leading experts at Bell.
Hey, welcome to the Bell Tech Talk segment of the Vertical MRO podcast. This is one of my favorite Vertical MRO podcasts that we do. This particular topic is something that's near and dear to my heart. This is going to be part 2 of the track and balance segment, talking about how to efficiently and effectively do track and balance on a rotor system. And that's something for me as a pilot that's bittersweet, and I'm sure it's bittersweet for all the maintainers. You come in and knowing you've got track and balance to do, and you're like, I'm not sure what I want to do. And as I'm thinking through this, I have somewhat of an icebreaker for you guys. And this relates to something I've been dealing with the last 12 hours. So it's a would you rather type question. So my question is, would you rather spend 12 hours playing cat and mouse trying to exterminate a skunk, or would you rather deal with a testy track and balance situation with the rotor system? And Greg Arnold, we'll start with you.
That's easy. Rotor track and balance any day.
I'm going to say, what day of the week is it?
Well, that's a good point.
Friday? Yeah. Friday, I'm not sure. I think I'll go chase skunks on a Friday.
Well, that's part of the conversation that part of the reason we're having the conversation with you guys is for folks to make this as simplistic as possible. And I realize in saying simplistic and not time consuming isn't really a thing when it comes to track and balance, but we want to make it as efficient and effective as possible. So I'm excited to go through this with you guys and talk about that. Like you said, Fridays are the last day that you want to be doing a track and balance, because you never know how long it's going to take, how many flights it's going to take. It could be a challenge. So before we kind of get into the nuts and bolts and the conversation as a whole, I'd like to just introduce you guys. Greg Arnold, you've been in the lobby of the Hangar Z podcast, of the Vertical MRO podcast, and the Bell Tech Talk podcast. So now we're actually here. So for the listeners who haven't had a chance to meet you at one of the shows or through Bell, can you give us a snapshot preview of your career and how long you've been at Bell and what you're currently doing?
Yeah, absolutely. So I have been at Bell 17 years. I have 36 years of experience, all of the time that I've had at Bell, where I was a CSE, 17 years of being a CSE, or tech rep, also known as tech rep in the industry. And the 36 years actually now, it has been rotorcraft maintenance the whole time. And I guess you could say I had a easy segue into aviation because my father was a Vietnam helicopter pilot, and I have really been around aviation all my life. So it's been a thrill.
Yeah, the Vietnam era pilots, man, they've not just pilots, but the industry as a whole. Man, I feel like in a lot of ways that was kind of the birthplace of current modern helicopter aviation. There was so much we learned during that time.
Yes.
I love the inspiration that comes from that era of aviation. For Greg Arnold, and we're going to call you Greg Squared for this conversation. 36 years as a maintainer, 17 years with Bell. Is that correct?
Correct.
And you were inspired by your father's time in Vietnam. Can you talk us just briefly through how you got to where you did educationally, kind of where you got your initial training and what it looks like today?
Yeah, absolutely. So I was fortunate enough to get hired by a company to come in as an apprentice and work on helicopters in 1989 while I was attending A&P school. Wrapped up A&P school in about 1990 and rolled into the industry. I switched jobs. I've been my experience has been mainly at MROs, but for the most part, I have been involved in EMS, law enforcement, ENG, charter, 135. I was at Dallas PD for about 5 years before I came to Bell. That was a career highlight there. It was always exciting. Enjoyed it. miss it some days.
Yeah.
Yep.
You're speaking my language. The public safety aviation sector is near and dear to my heart, as you guys know.
Yeah.
But thank you for your service in that
Yep.
arena of the industry. I really love the missions that are being done on the public safety side. And all the missions are great, but that one is just near and dear to my heart.
Yeah, absolutely.
Yep. Yeah, it's an important one for us for sure. You know,
Absolutely.
Prioritize those folks and our EMS folks.
Greg, Judd, I had the privilege of seeing you at Verticon. It's always great seeing you, but got to see you there, and I feel like the last couple shows we've had the chance to run into each other. So always happy to run into you at one of the shows, and really happy to get to talk to you today. For the folks who may not have heard part one or any other of the podcasts you've been a part of, can you give us a thumbnail, a snapshot of your career?
Sure. Yeah, I started in aviation, got into it, like Greg Arnold, 1989, and then was fortunate to I didn't work on helicopters right out of the gate. I worked on flight simulators, and I took a little bit of a sabbatical, went back to school, and started working on fixed wing stuff as well, but then got heavy into the helicopters again. So I've been involved with aviation at some level since '89 as well, but helicopters is where I really gravitated to. And before I come to Bell, I've been with Bell 12 years now. Before I was at Bell, I worked for a large operator in the Western U.S. here out of Utah. Fortunate enough to work for them for 13 years and learned a lot, did a lot of, it was EMS and utility firefighting.
Okay.
Such like that. So we had a pretty big fleet of aircraft. And I still, because of that, and like Greg, you create these relationships with all these folks that you see in the field on a fire or in the EMS when somebody's, the nice thing about the helicopter world is when it comes to fixing helicopters and needing help, there's no boundaries. They're the enemy. It's whatever we can do to help each other out because we focus on the mission, and that makes it a better place for everybody.
Absolutely.
You get to know a lot of folks. And then as you roll into this role as a tech rep, or a customer service engineer with Bell, you end up having those relationships. So it really makes it amplifies your ability to support folks. You understand their mission, you understand who they are, who you're talking to, and all that. And so
yeah, you guys are a quality group of folks. That's 100% sure. It's interesting you bring up relationships, and we talk about this quite a bit, how important those relationships are for career development, for troubleshooting. We talk about not having to reinvent the wheel. Yep. You go places and develop these relationships with the folks, and it allows you someone like phone a friend. You've got this person you can reach out to and be like, hey, how did you guys tackle this particular problem? The more people you have like that in your back pocket that you can reach out to and get some help from, I think the better. I love that you brought that up. It's just it's a necessary part of I think career development in our industry. It's a great community that we're part of, and we talk about that all the time too.
Yep. And that's why we want to do these podcasts, is to help share the knowledge we have. And like with track and balance, the one we're doing now, it can be so frustrating for folks. And we know that. We've been there, we've been frustrated, and we want to just give you all the ammo we can, all the tricks and tips, the tools in your toolbox. You can go out there and be successful and it not be a frustrating or painful experience or, negative experience, because we've all had those days where you roll in there and got to balance this, got to balance that. And 2 days later, you're still balancing it. You're still trying to figure out what's going on. And then other days you walk in there, throw the gear on, make one or two adjustments and you're gone. It's hit or miss.
Sometimes it's the actual equipment. Other times it's the pilot or the aircrew themselves saying, hey, there's something not right here.
Yep.
And you guys, you hook up all the equipment. You're like, well, I don't know. And it's fun. So it was funny. The last podcast you guys talked about, there was some troubleshooting that went into it. And actually the pilot's the one that realized, well, it was actually me. I'm the problem. I have a wallet in a place that I don't usually have it. It throws off the feel. So there's a lot of things, a lot of nuances that go into track and balance. We have just a little bit of experience between the two of you here to talk through some of the tips and tricks that go through track and balance. So if we could, I'd like to start. You guys, there's a recent announcement that you guys have regarding RADs. Can you guys kind of go through that recent announcement and what that means for track and balance?
Yeah, we were all excited to see the release of General Information Letter 2561, which announced the approval of the RADS NG. The RADS NG is the latest next generation GE manufactured track and balance equipment, and it is uses a laptop in place of a CADU. For those that don't know what a CADU is, I wish I had one here to show you, but it's pretty heavy, bulky item. You know, it's heavy enough that if you were to drop it, it'll punch right through a chin bubble and away it goes. But it's older technology, and it's good to see we've got some new technology to move forward with it. We're currently using it at our production facilities. Our training academy has it, and our flight research department has it, and using it as well.
The good thing is it's, we've validated it. Our engineering group has validated it. And one of the nice things about it is if you have an original RADS unit, a lot of the hardware is usable between the two. So you don't have to go out and buy a whole new setup. You can use your accelerometers, cables, cameras, photo eyes, all of that stays pretty much the same. So it helps in reducing the expense of it. But we've had good success with it so far. So
that's huge. I feel like with a lot of the advancements that technology brings, a lot of it comes with a hefty price tag.
Oh, yeah.
Because like you're saying, you have to go back now and retrofit a lot of the things that you already have. So I love that you guys have implemented this with, a lot of that stuff, the I'll call it the older, but the previous hardware in place. You're only having really to replace the computer itself, if I'm hearing you correct.
Yeah, there's two boxes that get replaced: the DAU and the CADU. So the data acquisition unit is the DAU, and it's a big, bulky box that all the cables hook into. Now you get a different box, basically, right, Greg? Did I say
yes,
that? Right?
Correct.
Yeah. It's a different collection box where all the cables come together and then plug into your laptop from there. So, and it's good. It'll be good. It'll be good for us. So
I'd imagine, based on what you're saying, with a laptop, you'd be able to visualize the data in a way that it might be more efficient and effective for you. Is that right?
Absolutely. Yes.
Yeah. The old RADS, the original RADS, I shouldn't say old, it is old, but the original RADS, rotor analysis, diagnostic, whatever, it was 70s technology.
Late 70s, yes. Really, early 80s, yeah.
LCD screen that was two colors.
Yeah. and the sun, you couldn't read it. The liquid crystal display would turn black when it got too hot. You couldn't see it at all. Yeah. Yes.
But if you needed to fend off wild animals, skunks for say or whatever, that was perfect for it because it was heavy enough to take care of business. So
yes.
As we kind of transition to the next segment, I want to talk about preparation for track and balance, because I think that's key, right? Ensuring you have all the proper things in place prior to going into it. I think that'll save you a lot of time. But
it's the key with everything.
Yeah, absolutely.
And you're doing, but in track and balance, way more important to pay attention to the little details. Because Greg will go into the details here, but I just wanted to get this out of the way. You can't balance dirt. You can't. You can balance dirt, but you're just wasting your time. But do your housekeeping, clean up, make sure everything's clean, tidy. The aircraft's tight as within reason. Obviously, you can't rebuild everything, but there's acceptable limits for wear on components, and that's what we deal with. And so, yeah, I mean, Greg, you put a bunch of stuff together. You've done this a lot. What do you normally do with folks? When you show up.
Well, ask a lot of questions. I know that in many cases they've already inspected the aircraft and looked things over. So I ask a lot of questions, and then occasionally, or most often, I will, if needed, I will climb over the aircraft and look at it myself, see if I can find anything. And it's not that the guys aren't looking for things, but some things that I have seen and experienced over the years, they may not have. So they just don't know how to look or exactly how to move the part to see if it has mechanical looseness. For example, the play between the wash plate sleeve and support, most people don't even take that into consideration as possibility for the inability to track and balance. So it's one thing that a lot of folks overlook. One of my most interesting finds was I drove 8 hours to help some folks track and balance a 407, and they told me they looked it over, but I thought I'd have a look myself and climbed up. First thing I find is the left aft corner mount, which is the most common corner mount to go bad, and it was in such bad shape that it was contacting the upstop, and that you could see fretting mud, from the two contacting each other in flight. And so, corner mounts aren't changed easily. So I ended up spending an extra day there while they changed the corner mounts out so we could move forward with track and balance. But yeah, he looked the ship over. The don't balance dirt. Martin in the last podcast mentioned that was mine. I can't take credit for that. That belonged to Dave Birch, mentor of ours, and
the guru of track and balance, Dave.
Yes.
So, we should clarify something here real quick, though. We're going to focus on just the 407 in this particular podcast. Okay.
Yes.
And the tips and tricks on that. So when Greg's talking about quarter mounts, they're unique to the 407 installation. We don't have them on any other aircraft. We have live mounts, but we have different mounting stuff. But just for clarity, 407 is what we're going to focus on.
Corner mounts.
Yeah. I appreciate that, and I appreciate the don't balance dirt. As we're recording this spring, and I actually saw a interesting photo. It was the back edge of a wing, but the same thing could happen on a helicopter rotor blade. There was so much pollen attached to the back end of that the trailing edge of the wing that it was affecting lift. And that it can go into what we're talking about here. So washing the blades, washing the aircraft, making sure that you're not tracking dirt. Balancing dirt. That's huge. So I think that's a really interesting point, and I think it maybe is something that most people don't consider off the bat.
Well, I can relate a quick story. It happened to me. We had an aircraft, bring it in, do some heavy maintenance over the winter. We had to touch up a few spots on the aircraft. I think we repainted the tail boom. We changed that number or something. We take it out. The thing flies horrible, but in our haste to get the aircraft out, we threw the blades on with a painter for putting the tail boom. Oh no, we didn't have them on. They were on the rack, and they just painted the tail boom, and they oversprayed the top of the blades. So there was overspray on the top of the blades.
Wow.
And we figured this out after, what's going on here? And Dave Birch and Dave Parkinson, our mentors, one of them said, "Hey, check and make sure your blades are clean." Well, we just put them on. We were just going through maintenance, but there was this layer of overspray on two of the blades that, they were dirty. We cleaned them all off. Didn't have to do anything really. We did some adjusting, but it wasn't point is, to your point, John, they're super sensitive to dirt and to contaminants, and so just be aware of that. Clean everything up.
Yeah, it's interesting, and I'll plug our previous conversation on aircraft washing. That's a whole art of itself.
It is,
because it really is. There's an actual science behind it, and if you haven't heard that one, I recommend going back and listening to the podcast we recorded on the science of washing your aircraft. Something else that I want to touch on is trim tabs. Can you guys talk about trim tabs and the importance of the prep work?
Trim tabs. So, a lot of questions come up related to trim tabs and where they should be set. Well, for example, when they're going to proceed with track and balance. And often if you've got a 2,000 hour 407 that you have never replaced the blades on, then there's no reason to zero the trim tabs unless you change blades. The trim tab settings, and so that 2,000 hour 407 and having the original blades, those blades would have gone through our whirl stand at Bell Helicopter prior to be put on the ship, and there would have been a trim tab setting that we stenciled on the root end of the blade where that trim tab was factory set to successfully track and balance that set of blades in a whirl stand. And that is a setting where with those particular blades where you're going to start with and leave that setting. And that would be your zero. But each blade would have a trim tab setting stenciled on it on the root end of the blade.
are you seeing a lot of folks actually set the trim tabs back to 0 when you go out there and do your initial walk arounds?
Yes. Not everybody. They often they'll call and ask questions, but in some cases we would set the trim tabs to 0. With a new, not necessarily with a new blade, but a repaired blade, refinished blade. The blade most likely will not fly like it did when it was new, because it may or may not have had a repair, or just the refinishing itself changed the profile of that blade enough that it would not fly like it did when it was new.
Okay.
Yeah. So to be clear, we use the tabs for a couple of things, but we use tabs for our initial settings at 35% torque on the ground, which I'm not aware of too many folks that actually do that. The 407 rotor head is a soft in plane type rotor head, so it responds differently to the adjustments than an underslung two-bladed or a fully articulated rotor head. So when we, like with the tabs, and to Greg's point, stenciled on the root is the tab angle that made that blade fly with the master. So I call that tab 0 versus chord 0. Chord 0 is in line with the chord. Tab 0 is what's on the root of the blade. That's the way I was taught to use that. And I think it calls it out that in the book. It calls tab angle, blade root tab angle is what it says. Set your blade to blade root tab angle. Anyhow, those tabs basically twist the blade, allow the aerodynamics to twist the blade more or less, depending on how you can do the tab. But as you accelerate, like in any other rotor, the tab becomes more effective because of the speed. Okay, so we keep that in mind. But the other thing stenciled on the blade root is the product balance weights that were set to the master, and we'll get into that here in a little bit. So you'll see some weights, upper, lower, and a tab angle stenciled on the backside, trailing edge of the root, where you can read it when you're standing on the ground looking at the backside of the blade.
The consequence of kind of not following the advice that you guys are giving is really just additional flights, right? Additional troubleshooting that isn't necessary had you maybe not done that.
Yeah, and compromising your ride. You may never get it as good as it could be if you don't. I like to be methodical with how we do track and balance on these aircraft, and I think Greg is in agreement. We stick to what stick accurate moves, and if something isn't working right, I always plot stuff. I tell them, hey, get your chart out, plot your moves on your chart, see where it went versus the machine. Then, if you need to do a correction or whatever, but that'll tell you a lot about what's going on, and back to setup. I know I said this in the first podcast about this, but don't get frustrated with us. And when we go, hey, double check your equipment install. We're seeing 180 out on this move here. That tells me, is the accelerometer hooked up? Is it wrong orientation? Is it upside down, pointing down instead of up? So there's a lot of stuff we can learn from just the data we get and what the move does versus how the aircraft responds to it, what it reads. So it's good to don't get mad at us when we say, hey, go double check that. Are you sure accelerometer one's hooked to the lateral or 4.5? Just double check that. So
yeah,
we see that a lot, and that gets I've had that happen where customers will get so frustrated with the track and balance, and they're 2 or 3 days in it, and they give us a call, can't figure this out. Hey, go double check your equipment. And then you hear this while you have them on the phone, or you hear this long pause, like, oh man, you know what I'm saying? And I feel for them because I have done the same thing.
Yeah,
I've gotten, you get target fixated. You're going to go out, you're going to work this rotor. I'm going to go handle this. 3, 4, 5 moves into it. This thing is not right. And, we all got a little pride, I got this. I got it. Then you start making moves opposite of what it's telling you. And it's not that. Just go back and check, it never hurts. Takes a couple minutes.
Yeah. How many, I can think of plenty of times where, I'm getting frustrated with piece of mission equipment in particular. And I'm like, hey, this is not working. What is going on? And my partner's like, it's off. And I'm like, oh, I'm an idiot. It does not work in the OFF position, Yeah. So it's, it's different, but similar in that you do get frustrated and you get fixated on what you're trying to accomplish and without realizing that it's something simple. Can you talk about hub balance weight? And what preparation does for that.
So for hub balance weight, typically, for an in-service helicopter, you're just going to do a routine track and balance. You'll leave the hub weight where it's at. The hub weight, mounts in between the grip on each blade, and they are Bell part number weights. Some are made of steel, some are made of tungsten, but overall, that hub weight is there just to balance mass, and then,
but not always. Not always.
Not always. Yes. On the 407, yes, there is that exception. It will affect track.
It does affect track, and more often than not, if you get a rotor that's smooth up to like 100 knots and then you start coming out, hub weight's my go-to for that. I'll look at the hub weight move first, because that you're not tabbing, you're not PCLing, and the hub weight will clean that up 9 times out of 10. And so that's where the soft in plane business comes in versus fully articulated or other, underslung. But yeah, I mean, we use it mainly for fore and aft balance, but not always. There are times where, and you'd be amazed at how little the amount of weight will make a difference. One of our Birch, our mentor, used to say 10 grams is a significant move of weight on a hub weight. And a 10 grams is is like an AN washer, right? Thick steel, right, Greg? Something like that. 2 of them.
Yeah. It's like 14 grams. Yes. Mm-hmm.
Yeah. So don't discount a move like that. If you're getting to the end, it works, and
it really does.
Yeah. So
I had a 407 that was an ENG equipped aircraft that we were struggling to get 60 knots in, and of course they fly at slower speeds, and we had a 0.2 at 60 knots, and 20 grams of hub weight fixed that for us. So
yeah.
No pitch link moves, no trim tab moves, just 20 grams of hub weight.
Well, going back to the preparation side of things, I think you guys, one of your points is, not setting the hub balance weight to 0. Are you guys seeing a lot of operators do that? And then if so, when is the appropriate time to reset that to 0?
Well, for me, what I usually tell folks is if you're installing a new multiple new blades or repaired blades, then we would 0 the hub weight at that point. Now, it's not necessary, because you're going to find out when you start checking the balance that the weight's either going to stay or it's going to come off. But if you're replacing 2 or more blades, I'd say it is okay to pull the hub weight off, but not completely necessary. So.
Yeah, like if you do a hub change, like you've got a timed out hub, you're putting an overall hub on. I always started with 0, because everything changes just a little bit there. I mean, but to Greg's point, you may not have any more runs if you throw the same weight back on. It'll adjust from either position. So, I mean, it's up to you. It's what you're comfortable with. But if you get repaired blades in there, sometimes the repaired blades can be so heavy that you end up correcting that with hub weight. And that's where it probably behooves you to strip the hub and go to 0.
Okay. Yeah. What about the pitch links and the length of those? What impact does that have? And as far, and I guess really in preparation for track and balance, what is your recommendation for that?
So as I mentioned earlier, you've got a 2,000-hour aircraft with the same original main rotor blades, then the PCLs would just stay as is. Unless, for some reason, somebody that's tracked and balanced it in the past has turned one of the rod ends all the way in or out, where you might run out of adjustments, because, there's a minimum and a maximum thread count that you can have on the rod end. So if one of those needs to be corrected, then, we always recommend that you do it so that you're not in the middle of tracking and balancing. That's the worst, when the technician crawls up and says, I can't go anymore on this rod end, and you're nearly done. That is not good.
You take about 3 steps back, because you have to pull it off, trample it, and try to get it close. And
yes,
I mean, you get pretty good at it. But the other thing I'll add to that PC link is when you're getting ready to track and balance, check your rod ends. Make sure they're good and tight. They're within limits. a loose rod end will play havoc in trying to clean up, finish up a rotor. You'll get close, but then you won't be able to finish it, and that gets frustrating too. So, but and keep an eye on your PC links, keep them clean, protect them when you're working up there. I've seen folks with Velcro sleeves that they put over them anytime they're doing maintenance with streamers on them. I wouldn't say they're delicate, but they're susceptible to damage when working around the rotor and with torque wrenches and all that. So just pay attention to that. And, you don't want to nick a tube or something like that inadvertently. So that would ruin your day for track and balance, and you'd be looking for another tube, So.
Absolutely.
I said that usually if you're putting like a new hub on, there's retorques for the through bolts, the lower cone and all that. And that's why you would have the torque wrenches and wrenches around those, let alone when you're adjusting the PCLs, you're going to adjust. And one last note on adjusting PCLs, when you're doing that, focus on keeping them lined up in the swash plate so they're square and they're square in the pitch horn. That makes your moves consistent with your threads. If you let one get off a little bit or whatever, I mean, we don't want them off too far anyhow because they can actually damage stuff. But just a little bit of thread difference changes how much you've moved that PCL. And for clarity here, we're talking millimeters. We're talking millimeters, not inches, half inches, quarter. We're talking millimeters. And when we start out of initials, we want to be less than, ideally less than 2 millimeter track between all four blades. So, a little move there goes a long way at the tip.
Yeah.
I digress.
I think the next point to bring up is aircraft CG and how important that is in the preparation for track and balance. Can you guys talk about that?
Yeah. So often we when I first came to work for Bell, I never even gave it a real thought. We get in the helicopter, we install the equipment, we go out and we fly, we check vibration levels, track, and then we come back and we make adjustments. And then, but it wasn't until, if I started running into these aircrafts that were more difficult to get tracked and balanced because the CG was so far aft. Now, in particular, an EMS aircraft, you got a pilot up front, maybe 170, 80, 90-pound pilot. You get a 500, 600 pounds of fuel in the back. Then you get two guys riding in the back. And often this is the case because, a lot of what I've done is gone out in the field to show people how to use a RADS and give them a little bit of guidance and familiarization with it. But I end up in the back of the helicopter along with them, and our CG's a little further aft. And what we've noticed is that the IPS levels will be, as much as an IP higher, when you've got the CG far aft.
And with EMS equipment in the back, in the baggage compartment and all that, and then air conditioning and all that, it compounds the issue. They're still within the CG envelope, but it's aft, so you have to think about that a little differently, how you're going to approach that track and balance. That's why we measure. Mm-hmm. We measure in the cockpit and in the aft cabin for vertical, because you may have a glass ride in the cockpit, and the aft cabin could be a 0.3. Yeah, and medics don't like working in that environment back there, where they're trying to help a patient trying to start an IV, and they're dancing around back there. It's just not the way it could be. It can be better. You pay attention to it. So
that's a precision movement for sure. I'd hate to be a medic. Your hand's bouncing around trying to. I'm sorry, I stabbed you in the forehead. I was trying to get your arm.
Yeah. More than once I've had EMS operators saying, "Hey, the medics are not happy with the ride in the back of this aircraft. We need to fix it."
Yes.
And to that point, just like we talked earlier about the pilots and the crew that are in this aircraft every day, they know this aircraft. Listen to them when you're doing your troubleshooting. It may be something totally unrelated to track and balance, but there's something going on with the aircraft. We've seen this, we see this a lot. Instrument mounts, instrument panel mounts, stuff like that will throw erroneous stuff, but it's because there's a vibration somewhere. Doors will be loose. You get a high forper when the cabin doors are loose, because every revolution of the rotor, that air, the downwash off the rotor impacts the cabin. So you get a forper. And so there's a lot of things, but that's the reason why we measured bolts, because we want to balance it smooth in both the fore and aft cab.
I think that's a great point, talking about utilizing your aircrew. We were joking earlier about how you can get some erroneous readings, we'll call them, from pilots or air crews on things. But as a law enforcement pilot, I would use my tactical flight officer as an instrument of sorts. When he's looking out the window at the left side, I'm using his head where he's looking as a kind of an instrument, a gauge, to figure out whether the target he's looking at is behind us, in front of us, or at 90 degrees. So, we were always kind of taught that use that tactical flight officer as an instrument. So you're kind of describing the same thing. It may not be a precision instrument all the time. It's not scientific, but it's a great tool to use when it comes to problem solving and helping to kind of work through this stuff. So I think that's a great point to bring up. We've talked about, making sure from the very beginning there's no mechanical looseness in your systems that may affect track and balance. Making sure the aircraft's clean. That's an important. We've talked about the trim tabs. We talked about that as well. We talked about hub balance, making sure that's good, and then the pitch links. So once all that's kind of done, and then we've dealt with CG. Kind of the last thing is to install the track and balance equipment. And we've already kind of alluded to how, that there could be some mistakes there, but assuming everything's installed correctly, you're kind of well on your way to starting the process. Any advice when it comes to installing that track and balance equipment for folks?
I do. I have some.
Yes, we do.
If we
Go
may.
ahead, Greg. Go ahead, Mr. Judd.
I'm a clean housekeeper. I like my cables tidy. I like them all tied together. I like them secured. I like the equipment secured in the cabin. I don't like it banging around. I've had some experiences where I've had to gather up equipment as we're doing different things as it's floating around the cabin. So run your cables clean, tidy them up, make sure they're tight, make sure they don't foul anything. You've got, like on the 407, your mag pickup on your swash plate. Make sure you have a service loop. Don't just bring it out of the stowage bag and put it on.
Yes.
If you pull up collective, you're gonna tear pull the wires out of the back of it. So just general housekeeping. If you're running the wires, off the camera on the nose, you come through the chin bubble, tape it down, tidy it up. I prefer to use Adel clamps on the screws for the landing light cover to hold the cable nice and secure so it doesn't get dancing around. Just stuff like that. But keep it away from the flight controls. Keep everything tidied up, just nice, clean, tidied up. It doesn't need to look like a rat's nest with cables in the back.
Silly as it may be, do you have a preference on the type of tape that folks are using to secure their cabling?
I prefer the metal tape myself. I don't know about you, Greg, but I like the metal tape.
Yes, absolutely.
Aluminum tape. It stays in place. It doesn't peel off, easily. Masking tape. I've seen people use masking. Not a fan of masking tape.
No,
I have used that. I don't know if you're familiar with gaffer's tape from the movie industry. I think is where it comes from. But it's really like a canvas type tape that's like really good.
Fabric embedded,
yeah, and it's good tape. It's good as well. But just don't put something on there that's peeling off as you're putting it on, and it goes through your tail rotor, or Lord knows where it'll end up.
Yeah,
because I know I've made a lot of mistakes in my life with track and balance. I shut down one time in a 407 and go, what is that noise? And I can hear this, and it's like, what the heck's that noise? And I had painted the blades, blacked out the leading edge of the blades, which you have to do on a 407 so the camera sees one black bottom. And there were I missed a piece of masking tape on the top of the blade, and as we flew, it didn't come off, but it was peeling up and going. And I heard it as the blades were coasting down, and it wasn't, the track and balance wasn't really going well neither, believe it or not. I know
that may have affected it a tad bit.
Might have. Yeah, I've seen the tape come loose where they route the cable for the tracker down to the chin bubble, and that tape comes loose and it's holding the cable, and then you got the cable smacking the chin bubble as you're flying along, and that's not a good thing. Don't know where it's going to end up. Or break the chin bubble was my fear that time. So
no kidding. Before we jump into product balance, can you guys, any last closing thoughts when it comes to the preparation that goes into track and balance?
Let's talk about fuel loads with the CG stuff.
Yeah.
When you're doing this, you want to be consistent. You want to keep your weights consistent.
Okay.
And the heavier, the better is we prefer. You don't need to be running max gross weight, but if you're running like 600 pounds of fuel, stay with 600 pounds of fuel. You may have to add fuel every few flights, but that's okay. Be consistent. The key is consistency in your moves, in what you're doing. Be methodical and consistent. And it's a lot easier for us to troubleshoot over the phone with you if we know, like we'll ask, hey, where's this, where's that, and we get a consistent answer back. Then we know things. We can do a lot better job of helping you as well with that. If that makes sense, I think.
Yeah, it's an interesting point. You had brought that up in the last in part one, and I hadn't considered that. And I think it's really important to consider using the similar fuel loads, like you said, for CG, because that could be the one thing that's thrown you out of whack. So I think that's an interesting point.
Well, and we try to balance with mission weights as much as possible. Like in EMS, if you're going out at 5250, then let's balance it as close as we can to 5250, because once the aircraft lightens up, it's going to fly fine.
Mm-hmm.
When it's heavy, if you heavy it up, they may fly different because you got more load on the blades. So the ride will change. And of course, in our aircraft, like especially 407, we recommend to check your ride every seasonal change, temperature swings. So, and you'll feel it. The pilots will report it.
Yes.
So, yeah, got a little bit of something going on. So,
yeah. Greg Squared, any last points of conversation for the preparation that goes into it?
Oh, yes. Good preparation. Main rotor blade paint. I know we've talked about that. Make sure that that's on there evenly. The that tracker measures the chord of the blade, and it's got to know exactly where the leading edge and the trailing edge of the blade is. And if you don't paint the leading edge well enough, if there's a bare spot or a break in it, you may get bad track data.
Tracker angle too. Make sure your tracker angle is correct.
Yeah, I have a little trick for the tracker angle. If you're using the sun shield, you can actually use the sun shield bracket and line it up with the screw hole on the PDOT tube, and that's pretty close to about 57, 56 degrees. So, just as a starting point, you always want to check it with the protractor, but you can kind of snug it up there and then make minor adjustments as you need it. And, I have better luck with the tracker angle from 55 up myself.
Yep.
But,
the same.
Those are the kind of pro tips that I think are gold. That's something you only kind of learn through experience or hearing someone like you guys talk about. So yeah, thanks for sharing that part. Going on to product balance. Can you talk about product balance and what its impact is and what we're talking about?
Yeah, absolutely. Tracking product balance was something that I feared. I was always afraid to just jump in and try it. And then, I took this job and obviously I had 19 years of experience when I started this job. So I thought I knew a lot. I didn't know nearly as much as I needed to know to do this job, even with after 19 years of experience, because I've never tracked product balance to 407. And, there's a lot of people that have not because they fear it, the complexity of it, but it's really not that difficult. And the idea is that we're starting, it's a starting point. So that's why we call it initial. And before I move ahead, I'll say there's two programs. There's an initial program and an initial PB program. The initial program was really developed for ships without product balance weights. You can use it to start your initial to do idle and 100%, 35% torque. But then you're going to have to, when you go to hover, you'll have to switch over to the other program. So my personal preference is to just use the initial PP program. And if I'm not ready to hover, I just stop after 100% check, the idle and 100% check before we go to hover, and make those adjustments to the idle. But I should, so the difference between the two is that initial PP just has you do a hover check so you can check the track change from 100% to a hover. And if that track change is significant enough, then the blades may require product balance to make them dynamically similar.
Yes. Yeah.
So the big difference is with the track is from where we're looking to make to see if it needs product balance is from the 100% to hover. And I just happen to have some product balance weights. I'm probably getting a little bit ahead, but I'll show you those in a second.
No, that's good.
The idea behind the track, the initial, is that we're just really focusing on track. Often, we just want to make sure that all 4 blades are in the same plane, dialed in as close as you can get them. And we always recommend to use millimeters as your measurement, because the millimeters are more accurate. And one thing people don't realize that use the inches is the rads in inches only measures down to 1/10 of an inch. So that's equal to 2.5 millimeters. You're not going to be able to dial your track in using inches as close as you would if you were using millimeters for your measurements.
Yeah. So, let me jump in here for a second, Greg. So let's get a little history lesson here. Initially, when the 407 were released, the only time you could do we in the field were never allowed to use product balance initially. They come out later on and finally come out with Bell come out later on and finally come out with a process for doing product balance. But that's set on the world stand, just like your cab angle. That's where they set the initial product balance. And heavy forward blade doesn't climb as much. Heavy aft blade climbs more. We control the twist of the blade and how it reacts with product balance. It's like a fine tune to a tab, but more accurate and manage. It's consistent. So that being said, when we're doing like from 100%, 35% torque to hover, the rotor's already loaded at that position. We're going to pull up into a hover. Now we're picking up the weight of the aircraft, and we want those blades to be within a couple millimeters, ideally. Mm-hmm. The time you spend here in initials pays back tenfold in forward flight. You reduce the number of forward flights flights you actually physically have to make if you take your time here.
Yeah.
So I wanted to make that point, right?
Good point. Yeah, absolutely. Yeah, there's a lot of stuff we miss as we're talking about this, and going through trying to explain it, because there's so much to it. It's really not that difficult, but the idea with the initial PB is if we were checking our track in balance at idle, 100% with 35% torque pulled in. And the reason we pull in 35% torque is because there's an axial plate by design in the mass bearing that will, if you're at flat pitch, it'll allow the helicopter to hop up and down. And it's really hopping up and putting control inputs into all 4 PCLs. And so you just kind of hop, and it'll, get a little worse if you don't pull in collective.
The mass lifts up and the swash plate stays, and then it pulls the PCs down. So then the blades get pulled back down, and it gets in this oscillation. And anybody that's flown a 407 know what we're talking about. First thing you do when you get in that situation, and one of the first things you want to do when you actually go fly, is check your rotor rotation RPM and get that dialed in as close as you can, and that usually takes care of that. And with the 407, I've had good success the higher side of the RPM, not the lower side.
Higher. Yes.
So you want your rotor a little fast, but still within the range. And that cleans up that ground hop usually, unless you've got something else going on, like a loose swash plate or something like that. But that's a different direction. We talked about that in the first one. So
cyclic positioning is important as well.
Yep.
So it's amazing. Just the little bit of cyclic movement will, clean up some of that hop ground vibration that you feel. In some cases, it may just be as simple as that the pilot, that the cyclic centering rigging is off, or it could be simply that the last mechanic that inspected the base of the cyclic stick inserted it back into the base of the cyclic yoke, and then when he tightened it up, he didn't get it centered. I mean, realistically, that cyclic should be centered in that yoke, and often they get it over. We typically get phone calls about that because the pilot's complaining about the cyclic, contact in his leg, because it's not centered up. But, if it's not centered up well, then, the cyclic position can be off a little bit as well.
Because like we are, the pilots are creatures of habit. And they're, John, you're used to it being in a certain quadrant,
Yep.
You know how it should feel when it's right. And then it's like, it doesn't seem right, So
Right.
There's little things like that affect everything. So, okay, I'm going to push it over here. Well, the cyclic centering light might not be on, but it might be right on the edge of that. And so now the rotor's loaded up a little different at idle or at 35. And, so you have to, it's just good to pay attention to that stuff. But let's get into this product balance stuff, Greg. Let's get on it.
Yes. So the typically when we do product balance, I mentioned the 2,000 hour 407 earlier. That ship, and it's got the original blades. It wouldn't need product balance adjustments necessarily, but most likely not. But if you've got a ship that you've just installed 2 new blades, 2 repaired blades, or a full set of new blades, full set of repaired blades, you're going to need to go through this initial product balance check to verify that those blades are stable from 100% to a hover, meaning that one of them doesn't climb or dive significantly more than 2 millimeters,
essentially,
actually more than 3 millimeters in flight. We try to get it as close as we can, but the way the program works is we're going to check it at idle, and we're going to adjust our track using pitch links at idle. We're going to dial it in as close as we can. I like to see zeros, across the board. Blue, orange, red, and green, or also known as Borg, the color coding. Easy way to remember the color coding is Borg.
Yeah.
Dial them in at idle, and then you're going to check it again at 100%. You're going to dial the blades in at 100% with 35% torque applied using trim tabs. And myself, I have learned from experience that it when you're doing the initial program, that hub weight is not as necessary to make adjustments on as track is. So I have gone through this where I will, check idle 100%, and I make all the moves the rad gives me. And then the next move, I'm taking the same hub weight back off again because I've made some different changes. And you'll go through that a lot. But in some cases, you don't have to just add hub weight until you go to a hover. So you'll check it idle 100%. You'll get those dialed all in as perfect as you can get before you go to a hover, and then you'll do your hover check. And obviously, the rads will provide you track figures for idle 100% and hover, and from there you just do the math, calculate whether the blade is 3 or more millimeters out of track from hover, from 100% to hover. So from 100% to hover, you want them dialed in closely. Now that might be that you've got a 1 millimeter on the blue blade at 100%, and then when you go to hover, it's 5 millimeters in a hover, and that would be one example of where you would have to do a product balance move on the blue blade. The other one would be is if you have significant differences between the blades in hover. If, for example, the blue blade was at a positive 5 and the red blade was a negative 5, then we would have to clean those up, most likely with product balance. And that's only if, and I wanted to have an example to show you, but the track, as long as the track at idle and 100% is, within a millimeter of 2 of each other, then there's not much you can do with the pitch links or tabs to make the hover come in.
Yeah.
Occasionally you could roll one down negative and it might bring it down a skosh, but may or may not.
And keep in mind, these initials are a starting point.
Yeah.
I've had more than one customer come back and say, hey, my initials are way out, but the aircraft's good. Well, it's a starting point. Don't go backwards. It's like rigging. Once you start and head down that road, unless we tell you to go backwards, don't go backwards. Go back and start double checking stuff. It's just, it's not worth your time, and it's going to change as you start working the rotor in flight. And one other point I wanted to make about product balance, like he said, we typically only see this on where we need to use it when we're mixing new blades with repaired blades, or a flying set of blades with a repaired blade pulling it in, or we have 2 repaired blades, or there's some other circumstance in driving drives us to do this, because the World Stand does a really good job of standardizing these blades to each other, to the master, which in theory makes them all fly together. I have had cases where the aircraft was doing just fantastic, and then all of a sudden a blade needed product balance. It's rare, but it happens. So if you have that happen, have a good look at your blades. There may be something else going on there that drives that. And then as we get in, you adjust product balance weights. Show them the weights, Greg. You got one there.
Yeah. So I have, this would be what a product balance weight looks like, if you can see that well. The weights, there's weights that are made of tungsten. There's weights that are made of steel, aluminum. They're different weights. There is a retainer. This retainer has threaded holes in it, which is for the cover to be threaded into. This would be for a forward main rotor blade pocket, and you can stack 3 weights on it, and the 3 weights,
any combination. Any combination of weights. It's important to note, though, right here, I'll jump in, Greg, is if you're doing product balance weight adjustments and you're moving weight from the forward pocket to the aft pocket, there's an overall weight package for that blade. You can't change that weight more than 8 grams. Is that right?
Yeah,
Greg?
7-8 grams, something.
Yeah, you need to stay, the note's in the book, but you need to stay within 7 or 8 grams of what your initial total weight was out there, because that affects the mass of the blade. As long as you're just moving it top to bottom, back and forth, you're okay. But you may have to use a spacer or a lightweight to make up the difference. You need to tighten up. You have to have the pockets the weights need to be tight in there so they don't vibrate.
Yes, I'll show you that real quick. There's these peelable shims that you just place over the retainer.
That locks it in. Yeah,
locks it in, and you can add 2 or 3. If you've only got 1/8 weight, you're probably going to have to add 2 shims, but they are peelable, and you want the covers on the blades to be flush with the skin of the blade. So obviously, you don't want to over shim or under shim the retainer and weight, or they will rattle in the blade, or the cover will stick out and it'll change the profile of the blade and your track and balance. So we have a limitation on what that cover can be.
I don't know about you, Greg, but it says to seal those pockets up. If I'm doing product balance, I don't seal the pockets until I've got the blades dialed in, and then I pro seal them. So don't put pro seal them on every time and they go fly, because you're just going to have pro seals. The sealant's going to be smeared across the blade. I mean, it's pretty common, but if you've never done this before, you may think, I need to seal this. If you're not flying in the rain and you're out working a rotor, which you really flying in the rain, it's hard to work a rotor anyhow, but you just want to make sure you don't seal that up till you're done. Otherwise you'll be cleaning up. So done making adjustments, I should say. So, but it's amazing to me how nice of a ride we can make when we do product balance adjustments on a rotor that maybe is mediocre at best, and then we can clean it up. And there are rare occasions where we'll use product balance in forward flight to fix a blade that's been repaired that maybe flies a little different, climber initially and a diver. We may change that product balance with engineering's permission.
Yes.
We can go in and get that change. We can use that to change mass a little bit. Now, here's the other caution I will say. Be careful when you're doing product balance and stay, like I said, the weight thing. Greg, you had it happen on one of your aircraft. We had a 2-per in a 407. We couldn't figure it out. It ended up somebody had messed up the weight packages in 2 blades, right, Greg? Am I remembering that right?
Yes, you are correct. Yes, I went out and I tracked and balanced the ship and got it dialed in pretty good, using our standard guidelines. But it still just felt horrible. It was like there was a rumble in the floor. And so we decided I being confused, we looked at the tail rotor, didn't see anything wrong with the tail rotor. Often you'll feel a tail rotor vibration in the floor of a 407, but we looked over the tail rotor, didn't see any reason that it was causing a problem, but we did go ahead and check the balance of it. But then it wasn't until I downloaded the information to the WinRads program, which WinRads is a laptop software that you can transfer data from your RADS CADU to your laptop to view it on your laptop. And often we use it. The main thing we use the WinRads for is to save the data for future, because the RADS CADU only has so much memory in it. So we save it for future use or for records, for example. But with this particular one, I downloaded it to WinRads and I looked and found that it had this higher than normal 2 per rev. So the only way we looked the aircraft over, we couldn't find any reason why there was a 2 per rev, but we ended up opening up the product balance pockets and finding that there was 2 blades opposing each other, that somebody had decided to add 80 grams of weight to the leading edge. And I think the track data led me to that, because I want to say that both of those blades dove significantly, and they both had up trim tab in. So yeah,
I remember that. I remember that. And that's another thing. It's not uncommon to have tabs up a little bit on all the blades, but when you see opposing blades that the tabs are actually working against each other, both of them up, stop. There's something going on. I'm a fan of the less tab angle, the better. Less likely to wash out, and less stress on the tab and the blade, in my opinion.
Absolutely.
Man, there's so many nuances, and little tips and tricks that goes into track and balance. I think, going as we started this conversation, as we went into it, I'm looking at our talking points, and I'm like, I don't know if we're going to be able to cover it. Well, there's no way. There's just so much for us to touch on, this conversation. It's so important because, the shops are spending a lot of time in this. So before we move on, we're at about an hour. Do you guys want to try and tackle another segment, or do we want to come back and do another hour, like a part 3 on track and balance?
Well, I think we'd be okay with part 3. There's still a lot of stuff there's a lot more to cover than I would rather do a part 3 than try to jam it in. But the one thing I would say, we learn as much from our customers when we're out and working these rotors as we do ourselves. Cause I know, Greg, you probably do, but I don't. I don't know it all, but
no.
It's amazing to me the little tips and tricks you learn from your customers. So, when we start these conversations back and forth with customers about track and balance, keep that in mind as a customer. You're educating us on your aircraft. Every aircraft has a personality or has its nuances, and every aircraft's got as in the first podcast, we talked about it. We talked about how the different aircraft have different frequencies, natural frequencies to the airframe, depending on how they're customized and all that. So we have to learn that aircraft. We've actually gone to the point, I think there was one aircraft where engineering actually wrote its own RADS program for that aircraft because of the customizing in that aircraft.
Yes.
Wow.
And so anyhow, the point is there's a lot. Martin covered it pretty good on the first one, actually really well, about the different frequencies and all that. But we learned from you, the customer, on each aircraft, what is unique about that aircraft. Now, sometimes we'll learn that, hey, we've seen this before and you need to pay attention. Go have a look at this. Something's going on here, and we can, there's some tips, like descending right-hand turns. If you got to hop in a descending right-hand turn, go like your quarter mounts. I mean, and a lot of times goes back to housekeeping. Before you get into rotor smoothing, jack up your quarter mounts and double check them. You can look at the tops all day long, and like Greg mentioned, they have to be really, really worn. The elastomers, they're elastomers. They have to be really worn out or torn before you contact the upstock with one of the quarter mounts. So there's damage, just because they're not contacting the upstock doesn't mean they're airworthy. You need to look at the bottom of them, serviceable. So, I was with the EMS operator just before the holidays, and we were talking about their mission, and they're going through quarter mounts pretty regular. I mean, 1,000 hours, 1,200 hours, but their mission is EMS, so they're leaving it near gross weight all the time. They're living in that environment, and that's just a byproduct of that environment. We can balance a rotor and with a lot of wear and tear in the parts. They're still serviceable parts, but there comes a point where it's a cumulative effect, and you're going to have to start cleaning it up at some point.
The concept you brought up, I think, is really interesting. A friend of mine, his name's Nick Minks. He runs a law enforcement aviation training company. He talks about this carrier pigeon concept that he experiences when he trains. So he trains air crews across the world, and he'll go to an air crew and he'll learn something that he's never heard before, and he'll take what he heard there and he'll then share that with the next air crew, and he calls it the carrier pigeon philosophy. And it's kind of what you're describing here. You guys talk to so many different shops, so many different experiences that you may not have directly had yourselves, but you've kind of worked through it, and now you can offer those solutions to your customers by nature and by virtue of those conversations you've had in the past. You're seeing a lot of the trends and the things that each individual shop isn't going to know or be aware of. So I think tapping into your guys' experience, whether it's through the podcast or through you guys, talking in person, I think is so valuable for the operators themselves. So I love that you guys offer that. And I always go back to your guys' customer ratings. They're huge for a lot of those reasons.
Yeah. Well, I will say what we're sharing here is stuff that customers have trialed and error and learned, and we've learned with them, or we've learned when we were a customer. And so I learned something pretty much every time I get into a track and balance evolution. That's really deep troubleshooting. You learn something. Either you learn it from an engineering group, or you learn it from another customer or another customer service engineer on our team. Somebody halfway around the world may have found something, and we have this weekly little email chain that goes back and forth where we, the Bell CSE, share information with our company. And you'll pick up stuff from that on occasion, like, oh man, I didn't even think about that. It's like, and it makes sense. But the point is, shame on anybody that would keep this stuff quiet.
Yeah.
If we want to improve the safety in the industry and improve the experience with our product, we're going to share everything we can, about this kind of stuff. In my opinion,
love it,
and that's Bell's way. We have a lot of top level support in our group, from our director to the VPs to and we're lucky, we're fortunate that way, because they stand behind us and they help us. They understand the value of being there for the customers. So it's a good thing all the way around the block.
Absolutely.
Greg's support isn't very good because he relies on me for that support. But I don't necessarily follow the same business model as everybody else.
We're talking about the community aspect of the rotorcraft industry, and what you're talking about is just that, trying to provide an opportunity for folks to learn from each other without having to experience the headaches of inventing a wheel themselves. Again, the wheel doesn't need to be reinvented. Let's, as a community, put our heads together and provide solutions, to make shops more efficient, effective.
I did real quick. I get these customers will call and say, "Hey, I got a dumb question for you," and I go, "No such thing." My automatic answer is no such thing, and I mean that, because I learn from every question that's asked. And, I may have an answer right off. I may have experienced it a week ago or a year ago and remember, hey, yeah, we had this with this or whatever. But there's always a little nuance to everybody's situation, so don't think. The point is, ask the questions.
Yeah. Get
us engaged. We're happy to be engaged with you and help you. And more than often than not, we'll travel out if it's an aircraft that's experiencing some stuff we've not seen before or we're not sure about. We'll just travel out, and we have gear. Our department has balance gear that we use for troubleshooting. We have a Zing, we have rads, and we use those. Honeywell ZTE kit and the rads, and hopefully soon we'll have rads NG. Available for us. But the point is, we can come out and double check your equipment with our equipment and make sure, it's not an equipment issue or something like that isn't easily diagnosed. And that's what we do. We're happy to do that.
Again, that level of expertise is huge. So thank you guys for sharing that, for leaning into your customers in a way that is truly supportive. Greg Squared, any kind of closing thoughts before we start walking through the end of this part 2, of which is going to be a continued multi-part process. As we've seen, there's lots of nuances here.
Yeah. So just, to add to what you were saying, I think that it's important that we share our knowledge. I don't know. I do it on a daily basis. But I get joy out of bringing and sharing that knowledge to people, and letting them know a good way, the right way, and not the wrong way to do their task, whether it be track and balance or not. And I know my experiences, if I don't pass them along, then people are going to waste days like I did trying to figure them out. So absolutely need to share our knowledge.
Yeah, to Greg's point, the customer success is our success. If the customer's not successful, then we haven't done our job. That's the way we look at it. We take pride in that. We take stake in those conversations. We want the customer to be, and I will say this, I have been in facilities where there's multiple different OEM aircraft there, and I've seen people, very frustrated with another OEM's track and balance or whatever. And I'll have a conversation with them. I don't, it's not that I'm going to talk about how to balance that other customers, other OEM's aircraft, but it's what it is I want to make sure they don't have the pitfalls the common pitfalls that are common across all track and balance. And so you just ask a few questions, and then you have a conversation. I had a conversation with these folks. Hey, step back, take a breath. Let's just review everything. And, I ended up leaving. I don't know where they ended up, but I'd heard later on that they ended up getting it taken care of rather quickly. They found something that wasn't hooked up correctly, and they went on their way. But that was just neither here nor there. The point is, when customers are sharing information with us and we're helping them become successful, then we're successful. And people, it makes it for a better experience all the way around the block. And the product is, utilized more. So that's a lot of this stuff. Our end game is we want you flying our product. We want you happy with our product.
The more availability, the more missions are being completed. Like I said, the happier folks are. So again, appreciate your guys' expertise, your passion for the industry. I always love talking to you guys because it's so evident how much passion you guys have for the rotorcraft community. So thank you guys for that. I think that's a big part of why our community is the way it is, because people are passionate about it. So
we need to thank you folks for giving us the platform to do this and helping us with this, because it's a great team. It's a great relationship here, and we want to continue that.
Absolutely. Yeah. We love these conversations. We love Bell, and we love folks like you, again, who are passionate about the industry and just, looking to make a positive impact in the overall well-being of our community.
This is what it's about, right? At the end of the day, it's about the relationships we have with our customers and with the folks in the industry that makes it such a good industry to be in. And hopefully that attracts more folks into our industry and, is part of it. So,
I think when it comes to the recruitment side, a lot of the recruitment that takes place is word of mouth from family members. And when your community is happy, you're encouraging your sons, your nephews, your family members to, hey, come join this community because it's really cool. Versus the opposite, right? You're like, don't come to this industry because it's negative. And I'm so thankful to be a part of this industry that isn't that way. At least from my perspective, it's been wonderful. An industry that I absolutely love, and these conversations are part of that. So
just one last thing. I'm sorry. Yeah. I will say, being involved with the rotorcraft industry, from firefighting to oil exploration and all that, I have met so many good quality people, not just in aviation, but in these small communities that helicopters end up in, that I have friends for life that I would have never met or even known existed had I not had these opportunities. Right. So it pays back in a lot of things you do.
Absolutely.
What you do. But this industry is really, it's exciting. It's fun to be in, and track and balance is just one little bit of it, but it's an important part of it. So
Yeah, that may not be the thing that people love about the industry, but we're here to help people through that,
yeah,
So
we're gonna make them love it. We're gonna help them love it. Yeah, that's what we're doing.
Greg Squared, any closing thoughts before we walk out of here?
Yeah, just call me if you have any questions. If you're not sure and want to know what Bill thinks or how we would go about fixing it, give me a call. That's what I'm here for.
Awesome.
I call him all the time.
Until part 3 of this track and balance series, we'll look forward to having this conversation again. Look forward to seeing you guys soon, hopefully in person, and we'll catch you later.
All right.
Cheers.
Thanks, John.
Cheers.
Thank you.
Yeah, my pleasure.
Take care.
Cheers.
Thanks for listening to the Bell Tech Talk segment of Vertical MRO Podcast. We want to hear from you. Have a technical topic for the team or a favorite technical tip? Let us know. Our email is techtalk@bellflight.com. That's TECHTALK@bellflight.com. If you're having a technical issue with the aircraft, as always, our team is here 24/7 at product support@bellflight.com. If you like what you heard, subscribe and come back for more.